Hello, we're continuing the video about limits that go to infinity. In the previous video, we looked at this example, and I want to point out that as this limit of 1 over x equals zero, that line in both directions where y equals 0, this is the asymptote for that function. Or you could say maybe y does not equal 0 to show that that's an asymptote. Now, for the function 1 over x, it's pretty simple to know what the asymptote is. It's more interesting to take a function, sometimes a rational function, and determine what the end behavior of the graph is going to look like using a limit. When you have something that's really complicated looking, especially a rational function, it's difficult sometimes to visualize what the graph's going to look like. So if you consider a limit where x goes to positive and negative infinity, it can give you a good insight into what at least the ends of the graph might do. Where the zeros are and all that kind of other stuff is still out there. But I want to use an example next, and that is expressed as a rational function. We'll do 3x to the fourth minus 2x cubed all on top, plus 3x squared minus 5x plus 6, and then divide it just by simply 3x to the fourth. And I'm going to go ahead and write it here. Limit as x goes to infinity. Before we do any math, this is just a question. It says, what happens to this function as x goes right really far? That's all we're asking here. So the simple way to do this is to realize that when you have x to the fourth and x cubed and x squared and so forth, the only term that really matters here as far as scale is the highest degree term. So what you could say is this limit behaves the same as this limit. And they're not, the x to the fourth term becomes so large as x goes to infinity that it basically overwhelms the cube term and the square term and the x term, and obviously the 6 doesn't add much if x is in the billions or tens of billions or trillions or whatever. So one nice thing about limits when you deal with them as when you have a rational function is you can really just look at every other term besides the highest degree term is not very important. And so you can see pretty quick that this is simply the limit as x goes to infinity of 1. And that's just 1, because if all the x's cancel out, then obviously what x is doesn't matter a whole lot. So that limit comes out to be 1. And what that tells me is this rational function goes really far to the right. It's going to approach an asymptote of 1. Now, I want to show you this a little bit more, once again, in a little bit more detail. Instead of you taking my word for the fact that each of these terms cancels out, I want to break it up into pieces. Anytime you have a rational function that's divided by one item, you can rewrite this as a bunch of different terms added or subtracted together. So we can do 3x to the fourth over 3x to the fourth minus 2x cubed over 3x to the fourth plus 3x squared over 3x to the fourth minus 5x over 3x to the fourth, and finally plus 6 over 3x to the fourth. And now you can even start simplifying it if you want to. I'll just do that for now. But all you really need to know is as x goes to infinity, if the power on the bottom is bigger than the power on top, this is ultimately going to go to 0, because the larger power on bottom means that the bottom number is going to overwhelm the top number. The denominator will overwhelm the numerator and make the bottom so large that this term basically ends up going to 0. But we don't have to do that yet. This is 1, minus 2 over 3x squared. If you simplify the x's, same thing here. 3's cancel out. You have 1 over x squared. One of these x's cancels out, so you have 5 over 3x cubed. And then this, I guess, can simplify to 2 over x to the fourth. And so when you let x go to infinity, you just have 1 minus 0 plus 0 minus 0 plus 0. Obviously, that just comes out to be 1. So this is one application of limits that's kind of outside of calculus. We definitely need to know about limits to deal with derivatives and integrals. But limits also can give you some insight into what a graph might look like. And here, the amazing thing about what we just done is you have this original rational function that looks awful. If someone said, what does that graph look like? You might have no idea. And you still may not have much idea, but at least you know that as x goes to the right pretty far, because the limit is 1, because the limit's 1 as x goes to infinity in English, what that means is as your graph goes really far to the right, this function is going to approach the number 1 forever. So that actually gives you quite a bit of information about your graph. And so from this video, remember that an asymptote and what x does is, what the function does as x goes to positive or negative infinity are the same thing.